그 학생들한테 링크가 어떤 식으로 전달이 된 거예요? 이거 원래 이렇게 적나요? 네 분밖에 안 계셔가지고. 아, 이번 주 줌 URL이 안 올라가 있어서 그렇구나. Hello everyone. Today we're gonna talk about the system performance monitoring and the regular expression. I'm very sorry for that. I did not know that we did not upload today's Zoom link, so I just uploaded. I think you are okay because you were here, so you already knew that, but I'm very sorry for your inconvenience. Today we're going to talk about system monitoring and regular expression. So let me take a look. Okay, good. So today we're going to learn about how you can monitor the system, and we will talk about the binary utilities and the way one of the useful tool for debugging called strace. I think someone did not mute. So let me mute it. And we will talk about how you can monitor the system. So we will discuss VMstat and IOStat, and also we will talk about regular expression. So let me talk about the binary utility first. So today we're going to talk about the object dump. This is a command line program that can display various information about the object file. It has several options there. So they actually they have a bunch of options there, but today we're gonna talk about only 3 options. The first one is a -D option. If you enable that, then the object dump will disassemble your program and give you the assembled code. And the -S is the it will show the contents of any section that you request, and the -X will show you all the available header information. So I think we have discussed I hope that you learn about the how ELF consists of. ELF has headers and the sections, and those sections contain some code, and the object dump allow you to get some useful information from that. If you want to know the other option, as always, the man page would help you. So if you type the man object dump, then they will have the bunch of the options there. So as you can see from here, they have a lot of options there, but today we're going to talk about only 3. So to test object dump, we need object file. So let's create some sample file. So here is our sample file, test.c. In this test.c, we have result, and we have a function add. This function adds 2 integers and return the addition of them. And here we get the 2 input using the scanf, and we store them into the A and B, and we call add A, B, and the sum, and we will print F and with the %s and %d, and %s is result, and %d would be for the sum value. So how you can compile it. So there are several ways to do that, but one way you can do is that you can split the compile and the linking phase. So first, we create an object file by compiling them, and by linking it, we can create the disassemble executable file. Sorry. So after we get the disassemble object file, let's try to do the disassemble this object. So as I said before, -D option is for disassembling. So if I do the -D, then you will see this kind of result. So here is the disassembly of this function. So you can see that it says it is add function, and this is the assembled code for the add, and this is main function, and this is the code for the main. So you can see here is that this add function is the red box is for the add, and this red box we call something. You can easily guess that because the first function that we call is a scanf, so this is the function that for the scanf. But here, this is the object file, which means that we did not do the linking yet. So it says it calls some function, but it does not know the name yet. This name would be displayed after the linking. So it says it calls some function, but that function would be eventually it would be the scanf. And similarly for the add and for the printf, it's just to show you the number. And when we do the linking, all the function names would be resolved. And there is a -S option. -S option will show you the contents of the section. If we type the -S with the text section, you will see that it will show you the content of this section. As you can see in the text, it has a bunch of the bytes there, which cannot be interpreted. As you know, those are actually code. So you can see the add is, if we consider its machine code, it is 554889E5. And if you see its content 5589E5, E8, those kinds of things are stored in this text section. And there is another section called the RO data section. As we know, this is the section for the read-only data. One of the The typical read-only data is the string. So you can see the result and the %d, which is for the scanf, and the %s, %d, which is for the printf. Those strings are stored in the RO data section. And your program actually contains a lot of other sections, and we can see those contents with the -s option. And you can also see that some available header information using the -x option. So it contains several headers, and it shows which section you contain and what's their size and their the mapping information, those kinds of things you can see from the object dump -x option. Yeah, this is the binary utility. So by using the object dump, you can understand how your ELF file, object file, is consists of, and what data are stored in this binary. And now I'm gonna talk about another tool, strace. Strace stands for the system call trace. And what it does is that it monitors the system call and the signals of the specific program. So if you run your program with the strace, it will show you the which system calls are you calling. And this is useful when you debug your program, particularly when you work with some assembly code. You want to know whether your system call is called accordingly, so you can use the strace for that. And there are two options. So you can trace the execution of an executable. So you can execute something and you can do the trace. And another thing is that similar to the GDB, you can attach to the running Linux process to monitor your system call. So here is an example. So if we do the ls mnt home, this is the ls commands, as you know, and it will show you that the content inside of the mnt home. How you can use the strace is that if you want to have some command that you want to run, and you can just put the strace at the first, then strace will monitor how your ls mnt home works, and which system calls are calling by this command. But if you run this, it will show you a bunch of lines, because program has a lot of, even though you did not call the system call explicitly, there are some implicit call related to the library routing, and some your C library also calls a lot of system calls, so it will show you a bunch of the lines. So it is very difficult to read. So what you can do is that strace has a -e option. If you put the -e and putting the system call name, then it will filter out your system calls and only show you the related system call. So if you do the -e open, then it will only show you the result of open system call. So this is the result. So you can see that if you do the strace -e open ls mnt home, it loads some files. This is the, I don't want to talk about the detail, but it is related to the locale. Locale is the information about which language you are using. Your library works differently according to your locale information. So this is the file that it tries to read for those kinds of things. So it opens this locale, and you can see that it opens this directory to read what's inside of this directory. So this is how strace works. So by using this strace, you can know that which system calls are using to implement this program. Oh, yeah. Changmin asked me that this dot for the empty byte. No, what this dot means that this is some character which is non-printable. So as you know, ASCII character, there are some non-printable characters. For example, if your character is beyond 0x7f, if I talk about it in decimal, if your ASCII code is greater than the 127, there is no character that represent this number. So there is no ASCII code related to that. So for that, what they do is that they put dot. So it says there is something, but which is non-printable. So you can see here that this dot, these two dots actually meaning the different one. The first, this U is 5, 5. The second dot is 8, 9, and third dot is E5. So those two dots are different. Dot means that those characters are non-printable. Okay, good. No problem. And in strace, you can get the multiple system calls by using the comma. So you can put the comma to trace multiple events. So if you want to trace the open and the read at the same time, you can do like this. So this is how it works. And from this result, what we can learn is that after open, there are no read to get entry list in the MNT home. So to get the list, we should get some information, but from here, what we can see is that the read is not used to read the entry. Okay, because if we trace the open and the read, we cannot see the read after open. Then which one is related to the reading the entry of the directory? So what we can do is that we can store the result into the text file. So -o option is for that. So if you put the -o and the output file name, your result would be stored into the output. And I believe that the working with the file is more easier than the working with the standard out. So after making a file, we can see what's going on there. And with the file, we can use a grep. So we can do the grep, and the -A3 means that we want to see the 3 more entries after our match. So if we have a match, it will show you the 3 more data after that. So let's see what's going on there. So here, what we can see is that it opened a file. It opened a directory MNT home, and its file descriptor to 3. And this file descriptor is used for the fstat. This fstat is something that is related to some metadata, statistical information, not statistical information. It will get some information about this file. For example, whether it is directory or whether it is file, whether it is a symbolic link, those kinds of things can be get by this fstat, and it calls the fstat. And one thing we can see is that there is some function which is get dents is called with this file descriptor. So we can see that this function does something with this directory. This get dents is a system call. Get dents stands for the get directory entry. So what it does is that if it gets the file descriptor from the directory, it returns you the information about the directory entries, some file entries inside of this directory. That's why it get directory entries. So from here, what we can learn from this asterisk, what we can learn is that to get the entries in the directory, we do not, our system do not use the normal read system call. Instead of that, there is another system called a get directory entries to read the entries inside of the directory. So those things we can learn from the strace. And as I said before, strace can be run with the execution of the executable, but also it can be used by the attaching the existing running process. So for that, we need a PID, processor ID. To get the process ID, you can use a PS command, PS-C, and if the program name, it will return you the PID. After knowing the PID, what we can do is that we can do strace -P and putting the PID, then it will run the strace with the running process. And then with this result, you can read that. And there is a tail -F command. If you put this, it will print out the appended data to the file. So if you want to run debug some long running process, you can use this one by putting strace to the already running the process and see what's going on there using the tail command. And here we talked about how you can check the system calls, and we talked about the binary utilities. And now we will talk about system monitoring tool. System monitoring tool is a program that can be used to monitor the system resources and the performance in a computer system. So I think some of you are taking the EE209. As you know, we had some issue with the disk in our EE-Lab G13 server. To know what's going on there, maybe you can use those kinds of tools to diagnosis to understand what's going on there. So, and in this case, we are talking about some program, and we see which program makes some trouble and why it makes some trouble. We can know from those kinds of things from this system monitoring tool. So in other words, if your program is in trouble, we can get some information from this tool to find out what is the problem. And yeah, we can identify if some process uses excessive resources and affects our underlying system. And this is usually used for the server management because there are multiple servers are there, and we need to use this system monitoring tool to know which process makes some trouble in our server. But it can be used for some program debugging though. Today, we're going to talk about two tools. The first one is a VMstat. VMstat stands for the Virtual Memory Statistics. I hope that you understand what is virtual memory, and it will show you the information about this virtual memory. In more detail, what it will give you is that it will show you the system memory and the processes and the interrupts and paging and the block I/O. So it will show you how a virtual memory works. And then what it does is that it run the program, specify a time interval in seconds, and it will show you the statistic between this time interval. So here, if we have a VMstat 26, what it will do is that it will report the result every 2 seconds. This 2 is it for the interval, and for the 6 iterations. So as a result, it will show you the 6 results, and it will take about 2 times 6. It will take a 12. It will take 12 seconds. And it will show you those kinds of information. Let's try to read what they mean. So the first field this R and B, they stands for the number of the process waiting for the runtime. So which processes are waiting, how many processes are waiting, and there is a sleep, but there is uninterruptible sleep. And I don't want to talk about the detail, but what this B means that they show you this number of the process in the uninterrupted sleep. And those are the important thing about this VMstat. It will show you the memory information. So swap D means that how much memory is swapped. As you know, if we use the memory fully, then some memory should be swapped out to the disk because we have not enough memory. So in this case, we do not have any swapped memory, which means that we have enough memory to support all the processes. And here is a free memory, which is some idle memory, which is not used. And there is a buff and the cache. Those are the memory used for the buffers and the caches. And there is a swap field. Swap field is that it shows the amount of the swapped in from the disk. So swapped in happens, but swapped out did not happen. SO means the swapped out. And this is the IO field. This is related to the device. You can think of it as related to the disk. And it shows you how many blocks received from the block disk and how many blocks sent to the block disk. So what we can learn from here is that there is no swapped out and there is a block sent to the block disk device. So we can know that there was some file write or disk write happens at this point. And it shows the number of the interrupts, how many interrupts happens, and how many context switch happens. And this is related to the CPU. US means time spent running the non-kernel code. So which means that running the non-kernel code is how many times are used for the application. So this is user time, and this is good thing because we spend some time for the application. And we have SY, how much time is used for the kernel code. And there is IO ideal time, and it shows also the waiting time. And it shows how your CPU is used to run each process. So kernel or the user or the kernel and those kinds of things. So by learning this data, what we can learn is that how our the memory is used and how our CPU is used. So by doing so, if there is some problem there, then we can learn what's going on to our system. So for example, let's assume that we have a bunch of the swapped memory. It means that it is likely that we are stressing with the thrashing, which means that every time the swapped out happens a lot, then we can know that something bad happened. It means that there would be some process that uses too much memory, so that our system is experiencing the thrashing. So those kinds of things can be achieved with this command. And there is an VMstat also has several options. So VMstat -S will show you the memory statistics. So what is the total memory and what is currently used memory and what is currently active memory and inactive memory, and those kinds of things will be show you. And there is a VMdisk -D. It will show you the disk statistics. So you can learn about how many reads and writes happen. Those kinds of things also can be achieved with the VMstat. And another one is related to the IOstat. IOstat is used to show you the more detailed information about how input and output works. It gives you the statistics. So IOStat has several options. One of the option is a -C. So if you put the IOStat -C and the N and M, then what happens is that it will show you the CPU information. -C means the CPU information every n seconds for the M iterations. So as you can see from here, those information, VMstat and IOStat is not kind of orthogonal. They show the similar information between them. And the -D will show you the disk IO information every n seconds for the M iteration. And the -P option will show you the specific device and how they are partitioned. So you can see from here. And the -X option shows extended the statistics, which means that they give you the more information. So here, if you see this, it has only 1, 2, 3, 4, 5 information. But if you use that -X, it gives you more information. These are the information given by the IOStat. So even I do not remember everything. So when you need, maybe you can find this IOStat and the VMstat information and check what those entries, what's the meaning of those entries, and which option should I use to understand the problems inside of my server. Okay, so we talked about the system monitoring tool. Now we will talk about the regular expression. Regular expression is a pattern used to match on the strings. So there are 3 types of the regular expression. Actually, there are a lot of regular expression types, but those are the typical one. The first one is a regular expression in a formal language theory. So this is a theoretical definition of the regular expression. And POSIX develop another regular expression, POSIX extended regular expression, because regular expression in theory is good, but it is not so convenient. So they added some extension. They made the ERE. And the PER made another regular expression called a PER compatible regular expression, which we call a PCRE. So when you use a program, normally we use this PCRE design. So their relationship, so they have some relationship. I don't want to talk about this, but the PCRE include everything inside of the ERE and the regular expression in the formal language expression. So we usually use this PCRE when you write a program, if you are not working with theory. So I talked about the formal languages. The regular expression in the formal language. There are a lot of languages in this formal language. So we have the regular expression, which is included in here. And we have another one with the context-free grammar. And we have another context-sensitive grammar. And there is an unrestricted grammar. This is the type that is recognized by the Turing machine. I believe you may heard about Turing machine. You can think of it as a computer. So it is some language that can be accepted by the computer. And this is the language that can be accepted by the regular expression. So regular expressions expressiveness is equal to the expressiveness of the DFA. I believe if you are taking the EE209, you have heard about the DFA. And I believe you have made those. The expressiveness of the DFA is equal to the expressiveness of the regular expression, which means that if there is something that you can represent with the DFA, there should be some regular expression that has the same meaning. So that's what they mean that their expressiveness is same. If you want to learn more about this, please take the Automata course, electronical engineering. I believe, as so far as I know, there is an Automata course. So if you take those course, you can learn what those mean. And how you can prove that the DFA is equal to the regular expression and how they are different. Yeah. So this is very, very informal definition of the regular expression. So given a finite alphabet, for example, let's assume ASCII code, and then what we can define is that we can define L of R. What this means is that it is matching strings with the regular expression R. So given the regular expression R, LR defines the means the matching strings with the regular expression. And there is a concept called a symbols. There is a character and the empty string. The character means that this is the some alphabet inside of this set. For example, A could be a character, and the L of A is a regular expression. If L of A, then the matching string would be just the set of A. And there is a special symbol called the empty string, which we represent it as an epsilon. L epsilon, the only thing that can be matched is the epsilon. So empty string only can be matched. Okay, so do you understand what those informal definition? So you can you see those? Can you understand those definitions here? So we have characters, and we have empty string, and we define a function LR, which returns you the matching strings. And with these symbols, we can define 3 operations. The first one is concatenation, second one is alternation, and third one is clean store. What concatenation is that the concatenation represented like this. So we have one regular expression, second regular expression, we just put them together. This is concatenation. The definition of this concatenation would be defined like this. So LR1, R2 means that the LR1, LR2, this means that it would be matched with some 2 strings A and B. A is from the LR1 and B is from the LR2. So for example, LAB is matched with the AB, LABC would be matched to the ABC. And the alternation, you can think of it as OR. So LR1 alternation, L2 means that LR1 union LR2. So it is okay to be matched either one of them. So LAB means that it could be matched with A or B. And what is clean store is that the clean store marked with the this asterisk. It means that the 0 or more repetition of your regular expression. So if we say LR1 star means that it contains epsilon. Epsilon means that it's 0 repetition, and that it is union with LR1 and the union of LR1 R1 and the union of LR1 R1 R1, and it would be repeated until the end. They're infinitely repeated. So if we say LA star, then the matching set would be the epsilon. It contains epsilon A and AA and the AAA, blah, 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 blah. Okay. So let's talk about the example. So one thing I want to mention is that clean star has the higher precedence than the concatenation and the alternation. So if we put the clean star is the highest precedence. So it should be take into account first, and the alternation has the higher precedence than the concatenation. So let's talk about this. Let's think about those rules and see this example. So if we have L, A, B, or C, then what would be the matching set? Is there anyone who can see what would be the matching set? All A, B, C. So here, oh, sorry, there is a typo. Alternation has a higher precedence than the concatenation. So alternation should be considered first. So this L, A, B, or C is equal to the L, A, B, C. Yeah, it should be considered as like this. If it is the case, what would be the matching set? Is there anyone? Yeah, it is AB and AC, correct. And what about this? Yeah, ABC. Now, what about this? LBA Kleene star. So as I said, because of this precedence rule, this should be considered like this. So then what would be the, yeah, so the matching set would be B, BA, BAA, BAA, BAA. Then what about this? L, A, or B star? Yeah, as Uzun said, epsilon A, B, A, A, B, B, A, B, B, A, 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 B, A, B. So that would be the whole string over the alphabet A and B. So I hope that you understand what's going on there and how this concatenation and Kleene star and the alternation works. Okay. So this is so what we have talked about is that the regular expression in formal language. This is a powerful, but it only has a limited operations and the symbols. This is good for proof, but bad for real usage. And that it can match. So there are some examples that shows the inconvenience of this regular expression in formal language. So if you want to match with any character, what you can do. In formal language, what you need to do is that you can do that, but it is very tedious. You should put the A or B or C or D or the blah 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 A or B or large A or B, or then you can make a regular expression that match with the any character. And for example, if you want to match with the alphabet, what you can do is that you need to A or B or C or blah 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 and Z. So this is a very tedious one. So what they do is that they have they made a ERE. ERE is POSIX extended regular expression. This is still in the regular expression boundary. So this is still the regular expression. So all the extensions here are the syntactic sugar. Syntactic sugar means that this is some kind of the expression that is supported by the language level. And this is something that is used for the making your expression more simpler. But this is not a fundamental difference, which means that it does not increase the size of the language that it can accept it. But all the things are just a syntactic sugar. So to avoid this kind of tedious one. So what ERE supports is that they introduce a meta characters. They use a dot. If you see the dot, it will match with any character. So instead of having this tedious thing, we can use just a dot to represent any character. And there is a match, the bracket matching. So what it will do is that it can match with a single character in the brackets. And this can be also used. You can use also hyphen to specify a range. So if you want to represent yours can be represented with the A and the B and the C, A or B or C. Instead of putting this, what you can do is that you can use this expression and if you put just the A, B, C, then it will match with a single character in the bracket. One good thing about this is that we can use a hyphen to specify a range. So if you do the A, Z, then it will be all lower characters because it is from A to the Z, small a to the Z. And if you want to represent all the lower letters and with the A, then you can put A, large A hyphen Z, then it would become A plus all upper letters. How you can represent all lower letters and all upper letters together with this bracket one? All lower letters and all upper letters. Yeah, you can represent, as Changmin said, you can do like this: A to the Z, large A to the Z. And there is another one is that you can, if you put this hat, if you put this cap, then it means that it will match any character except those in the square bracket. So if you put the square bracket, cap, and the ABC, this means it will be matched with all characters that are not A or B or C. And there is another meta character, cap. This is used to match the start position within the string. So if you put the cap ABC, that means that it will be only matched with the strings that start with the ABC. So for example, if you have string 11 ABC, and if your regular expression is cap ABC, then the ABC inside of this string would not match with this regular expression, but because it is now starts with the ABC. This cap is used for that. Similar to cap, dollar is used to represent match the ending position of the string. So ABC dollar, then it will be only matched with the string that ends with the ABC. And you can also define a sub-expression with the parenthesis. This is also called as a block or the capturing group. So if you have AAA with the parenthesis or BBB with the parenthesis, then this means that it would be matched with AAA and the BBB. So we can have this sub-expression thing with this. And there are another meta characters. A star is a clean star. Same with a clean star. It will have a 0 or the more repetition. There is extension plus is that instead of 0 or more repetition, it is 1 or more repetition. So if we have A plus, this means A. And we have 0 or 1 repetition, A question mark, then it will be epsilon or the A. And there is the curly bracket, and if you put the number, then it will be matched with the pristine element exactly m times. So if you put the C curly bracket 4, then it means it will be matched with the 4C. And you can also make some range between them, m comma n, then it will be matched with the 3 up to the 5 times. So A 3 comma 5, it will be matched with 3A, 4A's, and 5A's. Okay, here is an example. If you want to match with the meta characters, you can use the backslash to escape, similar to what we have learned from the C language. So we use the backslash for the escape. So similar rules happening here. So for example, a backslash dot braces parenthesis backslash parenthesis or backslash close parenthesis means that we will match with a dot open parenthesis or a dot the close parenthesis. So we can use this the backslash for the escape. Okay, here is an example related to the ERE. So if we have this ERE expression, then what would be the matched result? Yeah, so oops. So it would be, so HC plus means that it will be the H or C and it will be repeated one or more times. So H add, C add, H add, HH add, HC add, CH add, CC add, and those will be repeated. I think this should be CC add though. So those will be repeated. Okay. And what about this one, the next one? Yeah, so that will be had, cat, and at. We learned the question mark means that the 0 or 1 repetition. So it should be H, C, or empty string. So what about this? Yeah, this is C add, large C add, small d og, and the large d. So it would be cat, cat, dog, dog. And PCRE, there is another one is a PCRE. PCRE extended the regular expression with a more useful feature. So PCRE is more than a regular expression. So it becomes larger than a regular expression. So it is not, if we strictly say the regular expression, this is not a real regular expression, but we just call it as a regular expression because most of things comes from the regular expression. In PCRE, they introduced a character class. The backslash D shows you the digits, backslash large D shows the non-digit, and backslash S means the white space, backslash large S as a non-white spaces. So backslash W is the alphanumeric plus the underscore, and the backslash W is that the something that is not included this backslash W. Honestly speaking, those character classes are not something that make a PCRE unique, because as you can easily see, those are not beyond the limit of the regular expression's expressiveness, but they have more powerful feature in the regular expression. So they have I do not want to talk about this, but they have a kind of concept called back reference, subroutines. Those things would make this PCRE greater than the regular expression in the formal language. Okay, so let me talk about the assignment for the lecture 12. So if you go to this website here, it is a lesson, interactive lesson about learning the regular expression. So you can solve the challenges here. So it gives you the lesson about the regular expression, and it's what you need to do is that you need to add a pattern. So let me solve this first challenge. It says that the regular expression is blah, 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 and it can match with the common one. So what we can do is that we have these texts, ABC, 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 ABCD, ABC. So what would be the pattern that can match with the those three texts? So what would be the pattern? Yeah, that's one solution. Or here, it is okay. So in this one, it is okay if you have any match. So it is okay to give A as a regular expression if you have any, because here match means that we have any match inside of this pattern. Okay, so you can just put A, that would be okay. And as Changmin said, this is also okay. The dot is also okay. Anything would be okay. So let me solve this. And the second one is that related to the this number. So what we can do is that so this is also very simple. So you can just put the 1, 2, 3 here. But here, what they want is that they want you to use this character class. So \d is the character class related to the number. So if you put the \d, it would be the number. It would be matched with any number. So you can put the \d or any other things would be okay. So dot star means that it would be matched with any string. So if you have only the task with the match, then dot string would be okay. But I hope that you want to solve this one with it is better to solve those challenges the way that they want. So let me use the \d to solve those. And here it talks about the dot. This is something that is challenging here. What they want to do is that they want to match with those, but we should not match with that. So what would be the regular expression for this? Can you see how we can do that? Yeah. I think this is without you can put also dollar, but without dollar is also okay though. Yeah, so \dot, then it will be matched with dot. So those matching characters all have dot, so we can with the \dot to match with those, except for this the fourth text. So it has a lot of question. As so far as I remember, they have the 10 challenges. So what your task for this week is that solve all the 15 challenges and submit the answers. And in total, you will have the 15 lines. I think you will have the more than the 15 line because it has the 2.5 here. It is okay. So 1.5. Yeah, it was 1.5. So it is okay, but solve all the challenges and give us the answers. And put this one in and making a text file and submit it to the KLMS. Okay. Do you have any question about today's lecture? No, if you don't have any question, oh yeah. Yes. So if you are matched with some substring, that's okay. I think they will explain what would be. I cannot remember, but generally, if they say match, then it is okay to match with some substring. Okay, good. Then, okay, then we can stop here. Then see you on next week. Bye bye.